So we're going to jump into section 11.2. We're going to talk about surface area of prisms and cylinders. So in the first part of what we talk about today, there's a lot of new vocabulary. We're going to talk about a lot of vocabulary today. The first thing before we talk about prisms and cylinders is a lot of the solids that we're going to talk about in Chapter 11. Chapter 11 is about solids. A lot of our solids are what we call polyhedrons. So polyhedron is kind of like when we were talking about things with a bunch of sides in the plane, we have polygons. Well, polyhedrons are like polygons, except they're three-dimensional. So what we're going to say is a polyhedron is a solid that is made of pieces of intersecting planes. So we have all these flat pieces that are being put together to make a polyhedron. The sides are polygons. So we take these pieces of a plane that are in the shape of various kinds of polygons, we put them together into a solid, and that's what makes a polyhedron. So a lot of the solids that we're going to talk about in Chapter 11 are going to be polyhedrons. Not all of them, but some of them. So our first solid is a prism. And we probably have some idea of what a prism is, but we're going to make it a little more general. A prism is a polyhedron with we're going to have several things that this polyhedron has that makes it a prism. 2 congruent parallel faces and we call these faces the bases. So they have to be congruent, they have to be parallel, and we have to have 2 of them. And we call those 2 the bases of the prism. And the other faces are called the lateral faces. And lateral just means side. We're going to talk a lot about the lateral faces, the lateral surface, etc. Lateral just means sides. And we name them by the shape of their base. So let's draw a couple of pictures and name a couple of prisms. So the one that we're probably the most familiar with would be a triangular prism. So here's a triangle, something like this. And I'm going to connect these like so. Connect this, connect these. There would be a triangular prism. The triangles are the bases. So that's a base. This other triangle is a base. So we have two congruent parallel triangles as bases. And that's usually what we think of as a prism. We shine light through a triangular prism and it breaks it up into the spectrum. And these other surfaces, the other faces, are lateral faces. And we can also have let's draw another one. We could have a hexagonal prism. Let's draw one of those. I'm just going to draw a couple of hexagons here, and then we're going to connect our vertices. So there would be a hexagonal prism. The bases are hexagons. And our sides here, our lateral faces, would be rectangles. And I didn't intend it for the lines to exactly line up that way, but that's just the way it happened. We can make these lines if we wanted to. We can make them dotted lines. The ones that are back here, you can make those dotted lines. So there would be our hexagonal prism. All right, questions about the idea of a prism and how we name them? Okay, couple of important things that we're going to need to be able to find with prisms is the altitude or the height. And we'll usually, they're actually two different things, but we kind of use them interchangeably. Altitude. So I'm just going to put height. Altitude or height is the perpendicular distance between bases. So I'll say perpendicular segment between bases. So if we have, I'll draw a triangular prism here. So there's my prism. If I go from one base to the other base at a 90-degree angle, so I'm going to draw that in here, like so, and this makes a 90-degree angle. That's going to be my altitude or my height. Now the other thing that happens in chapter 11 is we will talk about bases of prisms, bases of polyhedrons. But for example, the base of this prism is a triangle. Well, the triangle also has a base. So we have the base of the base. So we're going to be using base to mean several different things. We'll talk about the altitude or the height. Well, the triangle that's the base of the prism also has a height. So all of these different things have heights. So we're going to be using the same word to mean a lot of different things. It's important that we keep track of exactly what we're talking about. All right, so we find the altitude is the perpendicular segment between the bases. Right prisms if we have a right prism, it means the base and the sides meet at a 90-degree angle. So it's not slanted. If it is slanted, we call it an oblique prism. That just means it's slanted. So if I were to draw an oblique prism here, I'm going to draw a rectangular prism. So there's an oblique prism. It's kind of slanted. And for these, we find our altitude or our height, just like we did for triangles, outside the prism. So this is oblique. Oblique just means slanted. For a right prism, the lateral faces are rectangles. For oblique prisms, the lateral faces are not rectangles. For example, here they'd be some kind of parallelogram. All right, we good so far? We know what the altitude is. We know what a right prism is. For the most part, we're going to be working with right prisms. The base area. We'll talk a lot about base area. Base area is the area of the bases. And the surface area is just the total area of all of the faces. I'm just going to say the total area. And that's really what we're interested in here. But we need all this stuff, we need to put together all this stuff in order to talk about the surface area. We need to know what a prism is, we need to know what we're talking about when we talk about a base, we need to know what we're talking about when we talk about a right prism, we need to be able to find the altitude, to be able to find the height. So all of these things are going to be important when we start calculating these things. All right, we're good so far. So what I want to do is start by finding the surface area using a net. We can always use a net, and we've talked about using nets in the past. We drew nets of different shapes in the past. We can always use a net to find our surface area. But we're going to use a net to talk about where our formula comes from. So let's talk about using a net. So here is we're going to find the surface area of this rectangular prism. Another name for a rectangular prism? It's just a box. All right, so this is 5 centimeters, 4 centimeters, and 10 centimeters. And we want to find the surface area. And we're going to use a net to do this. So I'm going to draw out a net of this rectangular prism. The nice thing about a rectangular prism is we can pick any of the two sides to be bases. I'm going to think of these two smaller rectangles. I'm just going to draw this piece in back here. The two smaller rectangles on either side as the bases. The bases don't have to be on the top and the bottom. The bases can be oriented any way we want. All right, so I'm going to draw my net. I know my drawing might not necessarily be perfect, but we'll get the idea here. Came out pretty good. And then we need to draw the ends here. So these are the two end pieces that I'm calling the bases. All right, so there's a net for our box. And I'm going to label the sides, the dimensions of the sides. So that's 10 centimeters. All of these are 10 centimeters. This is going to be my 4 centimeter side, and this is going to be my 5 centimeter side. So this would be 5 centimeters. This would be 4 centimeters. And these would alternate. This piece would have to match up here, so that's going to have to be 5 centimeters. This one is going to have to be on the top here, so that's going to have to be a 4 centimeter, and that one would be a 5 centimeter. Well, there are all my dimensions. And to find the surface area, we're just going to add up the areas of all these rectangles. So the surface area, I'm going to use SA for surface area, equals, well, I have 2 of these pieces on the end, so I'm going to say 4 times 5 plus 4 times 5. Plus, and then we have these 4 pieces. I'm going to say 4 times 10 for this one, plus 5 times 10 for this one, plus another 4 times 10 for this one, plus another 5 times 10. We can always find the surface area this way. We can always break it up into pieces and add the areas of all the pieces. So let's see. When I calculate, this is 20 plus 20 plus 40. I'm just writing all this out. Plus 50 plus 40 plus 50. And I add this all together, and I get 220 square centimeters when I add all that together. Well, these 2 pieces, isn't that just 2 times 2 areas of what the piece that I'm calling the base? That's 2 times area of base. And each of these has a 10 in it. So I could say this is 10 times 4 plus 5 plus 4 plus 5. I'm just factoring out that 10. Because if I distribute this, 10 times 4 times 5, etc., 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 I get this. Well, 4 plus 5 plus 4 plus 5. 4 plus 5 plus 4 plus 5. And what is that for this little rectangle? When I add the lengths of all the sides. What do we call that? The perimeter. So I'm multiplying 10 times the perimeter of the base. And 10 is the height of my prism. If I call these 2 sides my base, 10 is the height. So I have 2 times the area of the base plus the height times the perimeter of the base. And it always works out that way for prisms. That's where our area formula comes from, our surface area formula comes from. It's from breaking this into a net and adding up all the pieces. So now we're ready to write our formula. All right, questions on what we did there? So we'll write the formula next. Okay. All right, so our surface area. Surface area of a right prism. This formula works for right prisms only. Surface area of a right prism. We'll use surface area to mean surface area equals the height times the perimeter of the base plus 2 times the area of the base. So h is the height. B equals area of base. And our units are going to be units squared. Square inches, square meters, something. And B, capital B, depends on the shape of the base. So if our base is a triangle, to find capital B, the area of the base, we have to find the area of a triangle. If our base is a hexagon, we have to find the area of a hexagon. If it's a trapezoid, we have to find the area of a trapezoid. So our base can be any shape that we want it to be, so that capital B, how we find the area of the base, depends on the shape of the base. Sometimes you will see this written as H times P. We go back here. That's the area of all these pieces, all the pieces around here. Sometimes you'll see that called the lateral area. So you'll see the formula written this way, LA plus 2B, where this means the lateral area. B? Oh, sorry, P is the perimeter of the base. So P is the perimeter of the base, and if I go back here, that's what we got here when we added all these up. When we pulled that 10 out, we got the perimeter of the base. Common mistake with all these formulas is that students want to say the perimeter is the perimeter of everything. They want to add everything together. P just means the perimeter of the base. All right, so questions on our formula. Okay, yes?
Oh, so the A is for the area? Or
This, sometimes you'll see this written as lateral area, LA. LA just means lateral area.
is it just the same as
Yeah, so we would call this HP the lateral area. That's the area of the sides. This is the area of the bases. This is the area of the sides. Sometimes you'll see it written this way, and sometimes you'll get a question that asks you, what is the lateral area of this thing? And it means the area of the sides, not the area of the bases. All right, so let's look at an example. So we're going to say this is a right prism. And here is my there's one base. There is the other base, and I'm going to draw in my segments here. And I'm going to draw in my other, make these dotted lines back here. So, there's my prism. So this is a triangular prism, and I'm going to label some other pieces. And that's a 90-degree angle there on the triangle that's on the base. And that length is 8.7 inches. This is 9 inches. This is 8 inches. And this side is 10 inches. And this side is 7 inches. So because I have two congruent parallel triangles, this is a triangular prism. Our bases are triangles. We have two congruent parallel triangles and bases are. If it's helpful to you, draw out a picture of the base to help you find the area of the base, because our formula has the perimeter of the base and the area of the base in there. So let's draw a picture of the base. It can be helpful to draw a picture of the base. So here's my base. I'm just going to draw that triangle that makes up the base. There's that piece. There's this segment that makes a 90-degree angle that I drew there. That's 8.7. This side, it tells us, is 7 inches. And the longer side here is 10 inches. And this side is 9 inches. All right, so we need two things from the base. We need the perimeter of the base. So what's the perimeter of the base? How do we find that? (10 plus 9 plus 7). So that's 19 plus 7, which is 26 inches. Area of the base. B equals, how do we find the area of this triangle? Base times height divided by 2. So we have, to find the area of the base, we have to use the base of the base. What's the base of the triangle? 7 inches. What's the height of the triangle? 8.7. That's why we had that marked in there, 8.7. And we divide that by 2. Plug that into my calculator, and I get the area of the base is 30.45 square inches. Now I have everything I need to plug into my formula. So the surface area equals the height. What's the height of the prism? 8 inches, the segment that goes between the bases. 8 times the perimeter of the base, 26. That gives me the area of all these rectangles that make up the sides. Plus 2 times the area of the base. Because I have two triangles that are adding up in the surface area. So when I add this up, multiply this out and add them up, I get 268.9 square inches. So there's a little work that goes into finding the surface area of a prism. Sometimes for the base, you might have to use the Pythagorean theorem on a triangle. You might have to use special right triangles on a triangle to figure out some missing sides. You might have to use trigonometry on a triangle to figure out missing sides or to figure out the height. So all of the things we've talked about in the past come back to finding areas of bases of prisms. All right, questions on that example? Okay. Prisms have curved cousins. I call them curved cousins. Cylinders. And we'll get to why I call them their cousins in just a second. Cylinders are not polyhedrons. The cylinder is one of the shapes that are not polyhedrons. Why would cylinders not be polyhedrons? Well, they have sides, but the side is curved. We said polyhedrons were made up of pieces of planes. Planes are flat, straight, but the sides are curved. So a cylinder. I'm just going to call it a solid with parallel congruent circles as bases. So our bases are circles. They're parallel and they're congruent, just like with prisms. So we have two circles as bases. So that's one reason why I call them cousins. And one curved lateral surface. So we have our two circles as bases, and we have a curved lateral surface, a curved side. So the curved part and the circle part are why they're not polyhedrons. We find the altitude or the height exactly like we do for prisms. So the altitude or the height is the perpendicular segment between the bases. So let me draw a picture of a cylinder. So there's one base, there's another base, and there's my side. So there's my base. The height, or the altitude, I would go from one base to the other base at a 90-degree angle. And a right cylinder means the sides and the bases make a 90-degree angle. So what I drew here would be a right cylinder. And an oblique cylinder just means it's slanted. So here is an oblique cylinder. So let me see, I have this in my, just remember. So a right cylinder looks like a slinky that's straight up and down. An oblique cylinder would be slanted like that. So right cylinder, that oblique cylinder like so. So this would be oblique. We find the surface area of a cylinder exactly like we find the surface area of a prism. So that's another reason why we call them cousins. We have two bases, so we have to find the area of the two bases, and we have to find the area of the sides. So let me make a cylinder here out of this piece of paper. So here's my cylinder. And the circle, if we imagine this being a perfect circle, the circle at the end is my base. So we have two of those that contribute to the area. And then we have this curved side. Well, if I cut right along the side of a cylinder and I open it up, I get a rectangle. So there's my cylinder. One side of the rectangle is the height of the cylinder. There's my cylinder, like so. There's the height of the cylinder. And there's one side of the rectangle. The other side of the rectangle, when I open up that cylinder, is the circumference of the circle that makes the base. When I open that up, that's the circumference of the circle that makes the base. I open that up and that's the circumference. So that is where our area formula comes from. So our net for a cylinder is just a rectangle. That's our curved side surface. If I rolled that up, that's the part that would make the side. So there's my lateral surface. And then I need the circles. I know my circles aren't perfect there, but we get the idea. The circles that make up the ends, the bases of my cylinder. So my net for a cylinder looks something like that. Well, this is the height of the cylinder, once it's all rolled up. This is the circumference of this circle that makes up the base, the circle with radius r. So that's 2 pi r. So our area is going to be the area of these two circles plus the area of this rectangle. Exactly like we did for a prism. So that's where our area formula comes from, is breaking this into a net and finding the area of each piece. So let's write our formula for our surface area. Surface area of a right cylinder. So our surface area is the area of the rectangle. We'll go back to my rectangle. 2 pi r times the height. 2 pi r h. That's the area of that rectangle. Plus 2 of the bases, which is going to be 2 pi r squared. Square units. So we have the area of the rectangle that makes up the side and 2 circles that make up the bases. This is the lateral area. And this is 2 circles. So that's where our formula comes from. It's just like a prism. It's like a curved prism. So let's see. Let's mark our pieces. R equals the radius. And H equals the height. If we call B equals the area of the base, we could write this as the surface area equals the lateral area, just like we did for a prism, plus 2b. It's the exact same formula. The lateral area, the area of the side, plus 2 times the area of the base. It's the exact same formula we had for a prism. All right, questions there? Okay, let's look at a quick example and then we will be done. So what we'll do in general in Chapter 11 is we'll talk about our different kinds of shapes. We'll talk about the surface areas of kind of a family of shapes, and then we'll talk about the volumes of the same family. Because the formulas are the same. This is the same formula that we use for a prism, so we do these two together. So here's my, my right cylinder, and I'm going to say the radius here is 6 centimeters, and this is 15 centimeters. And I want to find the surface area. So I'm just going to plug my numbers into my formula. Cylinders are nice because they're not very complicated. There's less to them. So our surface area is going to be 2 pi. The radius is 6. The height, 15. That gives me the area of the side, the rectangle that makes up the side, plus 2 pi r squared. That's 2 of the circles that make up the base. And let's say we want to find the surface area in terms of pi. So pi, in terms of pi, just means we leave pi in our answer. So 2 times 6 is 12. 12 times 15 is 180. So that's going to be 180 pi. I just leave pi there. Plus 6 squared is 36. 36 times 2 is 72 pi. And I get 252 pi. I had 180 and 72. And that's going to be square centimeters for my area. That would be my answer in terms of pi. All right, questions? Okay. Homework. There's that. All right, I will pass your folders back, and then I will answer any questions we had on, let's see, is all we had to do the Common Core and Algebra review?